So starting on the first packet, question number 12. Because of a packaging error, a case of 12 cans of pasta sauce contains 5 traditional and 7 meat, all without labels. 7 are meat sauce, 5 are traditional. Okay, 3 cans are randomly selected. So what is the probability that all 3 are traditional? So that means traditional and traditional and traditional. So what are we going to be doing? Adding or multiplying? Multiplying. What is the probability the first can is a traditional sauce? 5 out of the 12 cans in there. Okay, but if I've taken out 1 traditional sauce, now how many are there? And now we've taken out another one, so now for the third can it is, so that gives us 0.0455. Does that make sense to everyone? So B wants a probability that exactly 2 are traditional. So that means we get 1 meat sauce. So it could be that the third one we pick is the meat sauce, or maybe the second one we pick is the meat sauce, or maybe the first one we pick is the meat sauce. So those are the different ways we can get 2 traditional. Or means add, so we have to do each of those probabilities, add them together. So the first one being traditional, how many traditional sauces are there? 5 out of, okay, if you've taken out a traditional, the probability the next one is traditional would be 4 out of 11. And if we've taken out 2 traditional, there's still all 7 meat sauces out of how many cans? 10. So now, the next time, the first can, there's a 5 in 12 chance of being traditional. We all have all the meat sauces left, so 7 out of 11 chance of being meat. And then traditional, we've already taken out 1 traditional, so 4 out of 10 would be traditional. Or, if the first one is meat, that's 7 out of 12. Then the next 2 are traditional, so that would be 5 out of 11 and 4 out of 10. So if you add all those together, you get 0.3182. Any questions on that one? So question number 16. So a life insurance company sells a $250,000 policy to a 20-year-old female for $300. The probability the female survives the year is 0.999544. Compute and interpret the expected value. When I say expected value, what is another word for expected value? Mean. So I'm asking you to find the mean of this. All right, how do we find the mean of a probability distribution? The mean is the sum of xt of x's. So, with the company, if the woman lives for the year, the company makes $300, right? So the value of x would be 300, and then the probability is the probability that she survives, so 0.999544. Okay, if she doesn't survive, what happens? And why is it 249,700 and not 250,000? Right, they got paid the 300, and so that you have to subtract that off of what they are paying out. All right, and how would I find the probability of this? Right, 1 minus the probability that the woman survives. So that would give us, all right, so then we have to add up the x times p of x's. So I have to multiply. And then we add those together. And we get an expected value or a mean of $186. So the company would expect to make $186. Is that one okay? So the next problem number 18. The probability a random patient who visits the ER will die within a year is 0.05. So part A. What is the probability that exactly 1 of 10 will die within the next year? So if you look at this, there's two possible outcomes. Either they live or they die. And do we have a set number of trials? Yes, we have 10 people we're looking at. Does everybody have the same probability? Yes. So what do we call this? This is a binomial distribution. So the number in my sample is 10. I'm looking when my x is 1. The p-value is 0.05. So you can work it out by hand, or this is one that is on our table. If we go to n equals 10, over to the 0.05, and the x equals 1, we get 0.3151. Does everybody see that on the table? If you did it by hand, remember the formula was n choose x, p to the x, 1 minus p to the n minus x. And it will give us the same thing. Okay, so part B, what is the probability that fewer than 2 of 25 will die within the year? So now my n is 25. Does our table go up that high? Yeah, it stops at 20, so we have to do this one by hand. We know if it's fewer than 2, what can x equal? 0 or 1. So we have to do 25 choose 0, 0.05 to the 0, 0.95 to the 25th. And we'll have to do 25 choose 1, 0.05 to the first, 0.95 to the 24th. Okay, and then how did you guys find it, the NCR on here? Do you remember? Okay. So do the first one. You do have some potential for rounding error on here as well, so depending on if you kept 5 decimal places here, or if you went ahead and rounded up because it was 498, so if you went ahead and rounded, you could have slightly different answers. Just another reason why it's so important to show me work. So we get 0.6424. what's the probability that at least 2 of 25? That means 2 or more. Yeah, so the easiest way to do that is 1 minus the answer we just got. And that gives us 0.3576. Okay, D. There are different ways of doing this one. What's the probability that at least 8 of 10 will not die within a year? So my N is 10. If I'm asking at least 8, then X could be what? What is the p-value? Yes, why is it 0.95? We want the probability they will not die. The flip side of this, you could have done the 0.05 and X could be 0 through 7 and found those. So there's a couple of different options. This one we are small enough in that it is on our table. So we can go to N equals 10, 0.95. We're going to add up the 8, 9, and 10. Add those. We get 0.9884. E. In a random sample of 1,000 ER visitors, how many are expected to die within the next year? Okay, expected value means what? Mean. If we have a binomial, look at your formula sheet. Under the binomial distribution, what is the mean of a binomial distribution? So the N, we had a sample of 1,000. P, we're looking at the probability that they die, so 0.05. And that gives us 50. Standard deviation, so we're still talking about the binomial. So that's the square root of N times P times 1 minus P. So my N was 1,000 times 0.05. 1 minus 0.05 is 0.95. We get 6.8920. Okay. Suppose some Christmas lights are designed so that the probability a bulb will last 2 years is 0.995. Each bulb is independent. So, what is the probability that in a string of 100 lights, all 100 will last 2 years? So the first one lasts, and the second one lasts, and the third one lasts, and the fourth one lasts. If they're all independent, if one goes out, does it change the probability of the next one? No. So what do we have to do? And means multiply. So you would have to take the probability of the first one times the probability of the second one times the probability of the third one all the way up to 100. Or the easier option is just say that's 0.995 to the 100th power. Get 0.6058. What's the probability that at least one will burn out? So what do we do? We get 0.3942. According to a poll, 17% of Americans bet on professional sports. Approximately 48.4% of the adult population in the U.S. is male. So part A, what is the probability that an adult is male and bets on professional sports? So the probability. male, and they bet on the sports. Okay. Do we have any conditional probabilities given in this problem? No. So we are assuming these are independent things. So that means this is just the probability of being a male times the probability that they bet on sports. So the probability of being male is 0.484. Probability of betting is 0.17. And if we multiply that, we get 0.0822. B, what is the probability an adult is male or bets on sports? So if you look at your formula sheet, the probability of E or F is the probability of the first plus the probability of the second minus the probability of both. So the probability of being male is 0.484 plus the probability that they bet on sports is 0.17. The probability that they are both is 0.08228. Gives us 0.57172. Questions on that? Of U.S. households, 17.9% are in the Northeast. So the probability they are in the Northeast is 0.179. If you don't know what to do on these problems, start writing it out like this. 5.4% are in 100,000 per year or more. So the probability of 100,000 plus is 0.054. Oh, sorry, and are located in the Northeast. What is the probability they earn more than 100,000 per year? So the probability of 100,000 or more, given they're in the Northeast. There's two different formulas for this. They're the same, just one is written as a division and one's written as a multiplication, so you can use either. So if you think the probability of E and F is the probability of E times the probability of F given E. That's the formula on the sheet. So my E here and my F are the things that we have. E has to be my conditional, so that would be the Northeast. So it's like saying 100,000 or more. But given they were in the Northeast, so this would be the probability they were in the Northeast. So 0.179 times the probability. And then the other side is our given, or sorry, our and, which we were given, let's see, that they were in the Northeast. So is this quite the same? Do we have everything we need here? We had, that would be my and right here, so 0.054. So being able to read your formula, figure out where you would plug things in. So now we just solve for the one we need, so we divide by our 0.179. And that is the second formula, it just sets it up as a fraction. So you could use either. So 0.054 divided by 0.179, 0.30167, so 0.3017. And 26. So a music player has 13 tracks, 5 of which you like. The songs are played in a random order and will not repeat until all 13 are played. So what's the probability among the first 2 songs? Part A, you like both. So you like the first one and you like the second. What's the probability that you like a song on here? And if it just played one that you like, what's the probability that you like the next one? Right. Part B, the probability that you dislike both. So you don't like the first one and you don't like the second one. So how many tracks do you not like? And if you just heard one you don't like, then the next one would be okay. And then that you like one of them. So it could be you like the first one and not the second one, or you don't like the first one but you do like the second one. So liking the first one, that would be 5 out of 13. If it just played one that you do like, then there's still 8 out of 12 that you don't. Or liking the first one, that would be 8 out of 13. If you played one that you don't like, then there's still 5 out of 12 that you do. Is there anything else on the first part that we need to go over, that first study guide? And let's go to the second. Alright, starting with number 1. Suppose you and a friend are playing a game where 2 dice are rolled. If you roll a 5 or 9 on the first roll, you win. If you roll a 4, 6, or 8 on the first roll, you lose. So first we need the sample space for win and lose. Okay, so we win if, I should have maybe made that more clear, I meant that when you roll the 2 die, it adds up to 5. So you can get a 5 by doing 1 times, or 1 and 4, or it could be 4 on the first and 1 on the second one. How else can we get 5?
2 and 3.
Okay. Any other way to get 5? Okay, but we also win if we get a 9. How can we get a 9? Okay, so we have 8 different combinations that would allow us to win. We lose if we get a 4. How do you get a 4?
2 and 3.
Okay. Or a 6.
1, 5, 5. 2 and 4. 3 and 3.
Or an 8.
3 and 5, 5 and 3. 2 and 6, 6 and 2.
Okay. So that's our sample space. Every combination that would allow for us to win or lose. So B, find the probability that you win on the first roll. So we have 8 combinations that allow us to win. If you have 2 dice, so there's 6 sides on the first one, 6 on the second one. How many different combinations does that give us? 36. So it would be 8 out of 36, or 0.2222. part C, find the probability that you lose on the first roll. So how many ones allow us to lose? Out of, so 13 out of 36 is any questions on that? So, number 4. A committee with 4 women and 3 men will select 2 people to attend a conference. What is the probability that 2 women are selected? So it's saying the first is a woman and the second one is a woman. So, how many people do we have total? 7. So the first one being a woman would be, and if you pick a woman for the first one, then there are 285. Number 5. So this one we have all of these different runways. And we're looking at paved or unpaved. So part A, the probability of being a paved runway. So if you add them all up, we had 5,146 that were paved. Out of, if you add that with the unpaved, 14,951. If you guys don't know where I get any of these numbers, please tell me. So that's 0.3442. Alright, so part B. This is still out of everything, so my denominator doesn't change. We want 914 to 2,437. So that's actually 4 different numbers you're adding up off the table. You want the 914 to 1523 and the 1524 to 2437, both paved and unpaved. So if you add those 4 numbers together, we get 5,661. So then that would be 0.3786. Did you guys get that one? So part C. Less than 1524 and unpaved. So there's not a given, so it's still out of everyone, but I'm only adding up the unpaved that are less than 1524. So that would be my unpaved that are under 914 and from 914 to 1523. So if we add those 2 numbers, we get 9,643. Did you guys see which ones I added together there? I need to put my table up on the board and show you. D, again, if it's not conditional, we are looking at everyone. More than 2437 and paved. So more than 2437 and paved, how many do we have? .027. paved given. So when we have a given, it's more than 1523. So my denominator is the condition. So we need to add up all of the ones that are more than 1523. So how many numbers are you adding together?
6.
Okay. So add those up for me. And what do we get? 2043. Okay, so cover up the rest of your table. That is all you are looking at. That 2043. And then of those, how many are paved? So you add up the 3 paved ones there, and that gives you 3.9207. F. And that's probability that it's less than 1524 given unpaved. So my denominator is all the unpaved. So we add up the unpaved, which is 9805. Then cover up all the paved. We're only looking at the unpaved. We already know it's there. Of those, how many were less than 1524? So we get 0.9835. Alright, G, the probability of unpaved, knowing, which is like given, it's less than 1524. So it's kind of like the previous question, but I switched your condition. Now the condition is less than 1524. So my denominator is all of them less than 1524, which was and my numerator is only out of those under 1524, how many were unpaved. So that's 9643. And you get 0.7471. Questions on that one? So we asked about number 6. So my numbering, it looks like, got messed up on this when I was copying and pasting questions. So you guys are meaning like the question that's actually numbered number 6 on here, not the question that came after 5 but was numbered wrong. I do that frequently. In a game of roulette, a player can place a $5 bet on the number 17 and have a 1 in 38 chance of winning. If the ball lands on 17, the player wins $15. If not, the casino keeps the 5. What is the expected value to the player? Expected value is the same thing as what? Mean. So this is, we could set up a probability distribution. We can list our x and our p of x. It's kind of like the life insurance question. And the mean, you have to add up all the x times p of x questions. So we're wanting the value to the player, not the casino. So if they place a bet, they are losing $5, right? So a -5 would be the first one. If we were looking at it from the casino's perspective, that would be a +5. So it doesn't matter which person we're looking at. So they have a 1 in 38 chance of winning. So to lose that $5, what's the probability? Yeah, you can go ahead and divide them, or think of it as 37 over 38, it doesn't matter. But if you win, you get $5, or sorry, $15. So how much actual money did you make? 10, and there's a 1 in 38 chance of that. So if we multiply these, add them together. And you get negative 4.6052 if we're talking about money. If you sat and played all night long, you would expect to lose $4.61 for every time that you played. So is it a good idea to gamble, guys?
Yes.
Brian, you did not get the life lesson there. I was trying. Okay. Question number 8. If x is a binomial, calculus probabilities. So we are, notice this one said calculate and the next one says use a table. So if I say calculate, you have to show me enough that I actually know you worked it out. So the formula, it's on your formula sheet, n choose x. So 4 choose 1. P, so 0.3 to the x power, so to the third. 1 minus p would be 0.3, or 0.7, 1 minus 0.3, to the n minus x, so 4 minus 1 is 3. So then you do this on your calculator, enter the 4 first, then go into your math, probability number 3. So 4 choose 1, 0.3 to the first, 0.7 to the third. So if I say calculate it, please show me what you're plugging in. Second one, my n choose x, so 2 choose 0. P is 1/4 to the 0. 1 minus 1/4 is 3/4. 2 minus 0 is 2. Alright, and if you plug that in, you get 0.562. Number 9 was the same thing, except I asked you to read it from a table. So everybody practice reading this from your table. So we're looking at n equals 15. So that is the very back page of our formula sheet. X is 3. P is 0.05. And you guys get 0.0307. B, we're going to go to when n is 8, x is 7, p is 0.95, and what do we get? So can everybody do the binomial either by hand, well, both by hand and from the table? Number 12. Okay, according to a survey, 20% of the victims say that it took 1 week to 1 month to recover from identity theft. A group of 14 identity theft victims are randomly selected in your hometown. Part A. What is the probability that none was able to recover from the theft in 1 week to 1 month? So when I look at this, if one person recovers, does that change the probability the next one does? No, so they're independent. That means they're separate from one another. Do we have a fixed number of trials? Only 2 possible outcomes? So this is binomial. My N, we were looking at 14 people. What's the probability that they recover? And my X that I'm looking at? 0. So we can look to our table, but we see we don't have a 14, so we have to do it by hand. So 14 choose 0. 0.2 to the 0. 1 minus 0.2 is 0.8 to the 14 minus 0, which is 14. So I get 0.04398 or 0.0440 if you round it to 4 decimals. B, what's the probability that between 2 and 4 inclusive? So that means X could be 2 or 3 or 4. So we have to do all of them. 14 choose 2, 0.2 squared, 0.8 to the 14 minus 2 is 12. And the easiest way is to put the first one in your calculator and then do second enter and change your numbers for each of the following. So if you put all of those in and add them together, we should get 0.67, 723. C, the probability that at least 5, so that's 5 or more. So you can add all these, everybody up to 14, which is going to be fairly time consuming, right? The other option, we've already found 0, 2, 3, and 4. If you find the probability of 1 using the same formula, that is like 0.15. Then what could you do? Yep, 1 minus all of these. So 0, 1, 2, 3, and 4, since we've already calculated those. And we get 0.1298. So you can either do that or calculate 5 through 14, which would take a little bit longer. And D, the probability that no more than 4. So that means X could be 0, 1, 2, 3, or 4. What's that? It's just the opposite of what we did on part C. We get 0.8702.